Section 3.2, example 10, integrating an even power of sine. Ooh, an even power of sine. So let's put our trig hats on very quickly. So I want you guys to remember the different values of cosine. So if we had cosine of 2x, like a double angle, there were a couple of different ways that we were able to write this. So one of the ways was had cosine squared a minus sine squared a. Another, actually not a. Let's just change this to a. If we let cosine squared equal 1 minus sine squared, we were able to turn this into 1 minus 2 sine squared a. If we let sine squared a equal 1 minus cosine squared a, we had 2 cosine squared a minus 1. And we had those three. So if we look at those three, this one doesn't really help us much with anything. But looking at this right here, if we solve for sine, we end up with sine squared a. So sine squared a is going to be equal to 1 minus cosine of 2a over 2. And if we do the same thing here, cosine squared a is going to be equal to 1 plus cosine of 2a over 2. So with that said, we could actually substitute that in for this right here. So starting off with that, the integral of sine squared x dx, we could use that substitution there and say that this is equal to the integral of 1 minus cosine of 2a or 2x over 2 dx. And this is actually not that bad of an integration. 1 over 2 minus 1 over 2 cosine 2x dx. Integrating 1 over 2, that's 1 over 2x minus 1 over 4 cosine of 2x, or not cosine, sine of 2x, and plus c. And there we go. There is the integration of even powers of sine. Now, if you have any questions, please feel free to ask. Otherwise, bye.